So this one is about a suction cup, and the thing about a suction cup is when you place it against some surface, there's going to automatically be a certain amount of air inside, and there's air outside too. And it's hard to believe, like, we don't feel it when we're just sitting here, but there's quite a bit of pressure due to the air around us. Like, we can't survive in space because there's not enough pressure to keep our bodies at the normal state that they're used to being in. So if you remove the pressure, it's a problem. And that's the idea behind the suction cup, is that there's a pressure outside which is equal to atmospheric pressure, which is 101,325 pascals. Quite a bit of pressure there. And then when the thing is not evacuated, the pressure inside is also at atmospheric pressure of 101,325 pascals. And then the suction cup wouldn't be expected to stay in that position. It would just fall down because there's air particles inside. And it's all about, like, how often and how hard the particles hit the surface. And so if they're hitting the surface from the outside and they're hitting the surface from the inside, then it all cancels out. There would be a weight that suction cup would have, and it wouldn't have any reason to be attracted to the surface that's touching right now. But what if you evacuate it by pushing? You push the air out, create a vacuum inside. What would it be like then? Well, then we could create a space in here where there's a vacuum. But you still have air on the outside colliding with the object. Alright, those tiny forces that it feels add up. They could add up so much that eventually there could be an upward force as well as a downward force. Now, they're saying that you're going to hang something from the suction cup. The suction cup's weight itself is not really that significant. But it could be significant if you put a force of tension by hanging something from it, mass of a student times g. So let's calculate what that force of tension would be. It would equal the person's weight, 78 kilograms times 9.8. So that's going to be 764 newtons. Alright, now we need the suction cup to create an equal and opposite upward force. But the suction cup doesn't really create it. It's the air outside that does, and the pressure from that air. And so we want an upward force of air, basically, to equal 764 newtons. Alright, so we want to use the pressure formula for this. So pressure equals force divided by area. We know the pressure of the atmosphere is 101,325 pascals. it tells you that it's going to push on things with that many newtons per square meter. And so we know the force that we want, 764 newtons. And we just don't know the area that's required. So the surface area of the suction cup is what we'd be finding then. So you just cross multiply 0.00754 square meters. Would be the answer. Now, how many square centimeters is that? Just because it's hard to conceive of how big that is. Let's see, it would be move the decimal 4 places. 75.4 square centimeters will do it.